Before we begin working this together, read through the problem, digest what's going on, even try to solve it out yourself first. So pause the video so you can do that, and then resume it after you've done that so our work that we do together will be more meaningful. Now, the first thing I notice is that since I'm dealing with a cylinder, this would be a really good candidate for making a drawing. So I'm going to draw a cylinder in order to be able to represent what's going on here. To draw a cylinder, I just draw two ovals and then connect the top and bottom with vertical lines. And then we're going to label it. Well, I do want it to look a little bit neater than that. So let's go with that. And I'm going to go ahead and label it with what I'm using as my variable names. So you'll see I'm using H for the height of my cylinder and R for the radius of my cylinder. And then I also labeled on here two numbers. Now those two numbers are so I can kind of keep track of what else is going on in this problem. That's the cost per square centimeter for each of those parts. The last piece of information that I'd like to write over here as well is the other number that we are given here, the 550 cubic centimeters of soup. Now, the fact that that's cubic centimeters tells you right there that that's a volume equation. And so the volume is going to equal 550 cubic centimeters. And then because that is volume, I'm going to go ahead and start with that as doing my equation over here. So we're going to go 550 equals the volume of this cylinder. Now this is a cylinder volume, and so to calculate the volume of a cylinder is going to be pi r squared h. We need two equations in order to be able to do this though, because there's also something we're trying to minimize. In this case, we're trying to minimize the total cost of our materials here. And so then I'm going to write a new equation for cost. I'm going to do C for cost here. And in doing our cost, there are three different pieces we need to look at all individually here. The first of those pieces, I'm going to go ahead and grab it now because it's kind of the outlier, and that's the top. So we know the top up here, it's a circle because it's the top of this cylinder, and that circle has a price of 0.07 cents per square centimeter. In order to write the equation then, I'm going to do that cost, 0.07, times the area of that circle. And the area of a circle is pi r squared. All right, so that's the top done. Next step, I'm going to go ahead and now take a look at the outside of the can here. So this outer part, basically like where the wrapper would be if you're thinking about a can of soup or something like that, the wrapper goes around the horizontal. We need an equation for that. Well, if you think back to your geometry work that you did so many years ago, if you do think about that as a label on a can, you could cut that label off and it would have a height of h, and the width of this rectangle would be the circumference of the circle, which is 2 pi r. And so if I want to give the area of that then, it's going to be, so I'm adding that on to my cost, the area of that is 2 pi r h. But I left a little space in front of it because I do need to be able to put the cost in there because this is 0.04 cents per square centimeter there. And then finally, there is one more piece to our can that we need to allot for our cup of soup at least. And that's that bottom there. For that bottom, notice it's another circle. The only difference between that circle and the one on the top is that on the bottom, it's only 4 cents instead of 7 cents. So it's going to be the same thing we did here, except it's going to be 4 cents. So we're going to go plus the 0.04 times pi r squared. Now, as I take a look at this equation, it certainly looks a bit overcomplicated at the moment. I want to be able to simplify it down a bit. And you notice that both of these terms are pi r squareds. One of them is 0.07 pi r squared, the other one is 0.04 pi r squared, but I can still add those together. And that would give me 0.11 pi r squared. And then plus, for this next equation here, I've got this 0.04 times 2. I could actually simplify that part of it and turn that into 0.08 pi r h. All right, that's at least a little bit better. But we're about to make it a little bit worse in a way, because remember, I now need to change this equation into one that only has c and one other variable in it. I need to get rid of one of those r or h variables. In order to do that, I go up here to the first equation, and I'm going to solve it for one of the variables. It looks like the easiest one to solve for here would be the h. So I'm going to do that. I'm going to solve that for h. And so that's going to give me 550 over pi r squared. All right, so I can now substitute that into our c equation. All right, looking at our resulting equation, I do see that there's a little bit of simplifying we can do here in this term. I'm going to be able to multiply this 0.08 by 550, and I'm also going to be able to clean up this r that's being divided by r squared over here. The first part's not really affected at all because there's not really anything we can clean up there. So the 0.08 times 550 gives me 44. And then I get to the pi, although you'll notice that I have a pi in the bottom of the fraction there too. So actually, that pi is just going to cancel out with that pi. So no more pi's. And then we have the r over the r squared. That would leave us with 1 over r squared. Because I do know that we are going to be taking the derivative of this, I'm going to go ahead and just call that r to the -1 right now, just to make my life a little bit easier. Because the next step is to find the derivative, because we're trying to find the minimum of this function that we just wrote. And finding the minimum means finding the derivative and setting it equal to 0. So let's go ahead and do that. And now that I have my derivative equation, I'm going to set it equal to 0. And then it's down to algebra, solving that equation for r. I'm going to go ahead and add this 44r to the -2 to both sides. And I'm going to turn that r to the -2 into 1 over r squared, just because I think that's going to be easier to work with in our next steps. And then that still equals the 0.22 pi r. Because I can now get rid of that r squared on the left by multiplying both sides by r squared. And so then I have 0.22 pi r cubed. Now it's a matter of figuring out what r cubed would equal. So I'm going to divide both sides by this 0.22 pi, which equals 200 over pi, or about 63.66. And since I am going to be taking the cube root of both sides in order to solve for r here, I am going to go ahead and use the decimal form. Although if you want to leave it exact with pi in there, that'd be fine. And when I do that cube root, it gives me an answer of about 3.99. And just because I want to make our last little step there just that little bit simpler, I'm going to go ahead and round that to the 10th, which would be 4.0. So I'm just going to go ahead and call that 4 here. If you're doing a problem like this on a homework assignment or something like that, always check to see what it's asking you to round to, because that'll also help you to know what you can get away with in that regard. Now, once again, though, all we found is the radius. We still need to be able to figure out what is the height of this. And so earlier, remember, we did find a height equation. And now I can go ahead and plug the r value that we found into that in order to be able to figure out what the height would be. And when I did that calculation, I went ahead and used the entire exact decimal that I got back here, just so I didn't have any rounding error in the middle as a result. But I got an answer of about 10.98. And so there is our radius and height that would minimize the actual cost of making this cup of soup.